Alright, so let's go ahead and start this one. Okay, so this is chapter 9 intro. Okay, so is Miss Gallus a good free throw shooter? First of all, it's not a picture of Miss Gallus. That's a picture of Shaq. Miss Gallus claims that she's an 80% free throw shooter. To prove her skills, she shoots 50 free throws and makes 32 shots. Is Miss Gallus exaggerating about her free throw skills? Yo. So, for the population, it's going to be all free throws shot by Miss G. Okay? And then the sample is going to be 50 free throw shots by Miss G. And then you got P, which is the true proportion made, which is 0.8. And then the statistic is P hat equals 32 divided by 50, which is 0.64. So that's actually what we found. Two possible explanations for why Miss Gallus has only made 32 out of the 50 shots. So first of all, Miss Gallus is an 80% free throw shooter, but had an off day. Or Miss G be lying. So she's exaggerating. Okay? So the null hypothesis is that you've got HO equals P, which is 0.8. Okay? The alternative hypothesis is going to be HA, which is P is less than 0.8. Okay? Right? So, if we scroll down, so to test Miss Gallus's theory, or her claim, we will assume, number one, she is an 80% free throw shooter. So this is assuming the null hypothesis. Okay? And examine the likelihood that she makes 32 out of the 50 shots through simulation. So you're going to use the spinner provided to simulate 50 free throw shots by an 80% free throw shooter by spinning 50 times. What is your sample proportion of shots made? Repeat another sample of 50 spins and then calculate the sample proportion. And then add your sample proportions to the dot plot on the board. Each person in your group should add 2 dot plots to the board, sketch the dot plot below. So it's going to look like this. Actually, I'm going to pause it and then y'all can write that down. So if you write this down on your paper, and I know you're probably going to need to pause the video, you're going to see that you only got one that's kind of like chilling way far away from the rest of the data. So that's your one out of the 53 free throws that are not around this grouping. Okay, so looking at what does each dot actually represent? Okay, so what does each dot actually represent? Each dot is the proportion of free throws made from a sample of 50 free throws by 80% shooter. Okay, one student says each dot represents the proportion of free throws made out of 50 free throws shot by Miss Gallus. Is this correct? Explain. So no, because we don't know if Miss G is an 80% shooter. The dots represent a proportion of made shots by an 80% shooter. So we're not confirming that she's an 80% shooter. We're just saying, hey, we're accepting that she is right now. Okay? What percentage of the dots represent a percentage of 64 or less? 1 out of 50, which is 2%. And that's going to be our p-value. Okay? So interpret this percentage in context. So assuming Miss G is an 80% shooter, there is a 2% probability that Miss G makes 32 out of the 50 or less throws purely by chance. And then it says on the last question, based on your answer to question 8, does the observed p-hat of 6.64 result giving convincing evidence that Miss Gallus is exaggerating? Or is it plausible that an 80% shooter can have a performance this poor by chance alone? We have convincing evidence that Miss G is exaggerating. Because 2% less than 5%. It is unlikely 80% would perform this bad. And this is your conclusion. Okay?